point, our recording has begun. I'm going to start getting to our topic. It's Easy CNC with Sinumerik 808D for milling. So if you guys could just bear with me a second, we're going to look up our PowerPoint. This will be a PowerPoint presentation as well as an interactive live demonstration. I'll use PowerPoint just to kind of navigate us through the content that we want to cover here today. Alrighty. Everybody should see the PowerPoint here on the screen. Let me open the chat window if anybody has any clicks that pop up. Okay, so again, I said this is for Sinumerik 808D milling. I'm your first Chris Plick. I'm with the dealer support team. This is contact information, and I'll give it out again later for those of you that may not have my contact. But I was also the one that initiated the emails that came out, so I'm assuming most of you guys already know me. Just as a quick little overview of the key goal here, basically what we want to do is we want to be able to step through an axis milling scenario in the 808 control. You're going to find a lot of similarities between this product and the other versions of the control platforms that we market. I'm going to point out where things are the same and where things are different. And if you guys, use different control series than this one, or bouncing the two, you can use some of the functionalities here and apply other controls. So we're going to go through machining, moving the machine around in jog mode, set some part zeros. We're going to do programming, and then we're going to verify the parts we program and even simulate it in auto mode. Programming example for today. I will try to jump back and forth when it's necessary, just so you guys can refresh the shape. But just talk about it briefly. We're going to face off the top of this part. We will machine this irregular OD profile, and we will drill some holes in the profile. Just giving you a basic overview of the operations it would take to create a pretty standard part program. We're going to talk about our jog mode. Quick snapshot of the first screen we're going to see, which is our primary jog screen. We're going to talk about functions like TSM. TSM is an area where we can tool changes, fire up the spindle, do different M code statements. We'll step through some of the tool functions, as well as measuring part functions, some of the canned features that are built into the control. At the offset tables, take what it takes to create a tool in a system, the tools that we support, and some maybe the unique things within that table here. What we're going to do is we're going to transition that content into a live demonstration. So at this point, what I'm going to do is I'm going to fire up our offline programming we call 808 on PC. 808 on PC should be loading on everybody's screens right now. 808 on PC is an offline programming tool. It's completely free of charge. You can download it or gain access to it from our website, which is CNC.com, and that's CNC, the number 4, IOU.com. From there, you just there's a couple links to get to it. You download it. You do have to initially register, and once you register it, you get a code, and it's completely live. There's no charge for 808 on PC. What we're looking at here is we're looking at our basic jog screen. Jog, because if I look in the upper left-hand corner, I see that my little jog display is up here, right in the upper right. You see my mouse kind of hovering over it. Our axis display. This case happens to be commissioned as a 4-axis machine. You have your X, Y, and Z display. The position display will be driven off of the 3 buttons in the lower right-hand corner of the screen. Real is like a temporary, momentary 0 position. The actual value based on WCS will show you your values based on your work coordinate system. If you want to look at things based off the machine coordinate system, you can toggle MCS and change things to machine coordinate system. As you start to load different offsets and set zeros, you'll see these numbers will change based on these 3 different scenarios. To our TFS window, TFS stands for Tool, Feeds, and Spindle. There's a monitor down here, and it'll tell you whatever tool the machine fits in the spindle at that point and what offset is called up for it. what current rates are initiated, and if the spindle is performing something, it'll tell you what spindle speed is. Then you have our lower horizontal soft keys, and the soft keys will allow you access to any of the functions we've incorporated in the screen. So first things first, we have the TSM screen. TSM stands for Tool Spindle or M code. TSM really is a way for us to not need to leverage a function like MDI. The control have MDI in it. You click the hard button represented down here on the hard panel, right here for MDA or MDI. MDA stands for Machine Data Automatic Functionality. You wanted to do consider traditional MDI inputs. But with TSM, it's going to pretty do a lot of the typical stuff that you know you would normally want to do, like a change. For if I knew I wanted to tool change to tool 1, I can place a tool 1 in this field, select cycle start, reset state. All right, tool change. You see tool 1 is now loaded into the spindle, and you can start to place any of the tools that are carousel. This would initiate a full tool chunk of tool 4, loads tool. Just from having to go in to the index statement, the additional cheat code statements you might be used to. Spindle can be triggered through here as well. So if I want to start the spindle at some RPM, type defined RPM, down to the spindle direction field, select key, which is in the middle of my blue arrows, clockwise, counterclockwise. Select an M3 for clockwise, and then I'm going to update that command with a cycle start. From there, the machine would start up, clockwise mode, be spinning. All right. The spindle buttons themselves, just below the side knobs, I can start the spindle now once I've initiated an arm with these buttons. To use this function to activate work coordinates, on the center of the screen, I can see the current work coordinates activated by seeing G54. And now I can toggle through any of my work coordinates 54 right up through 59. So I'm going to do G55, cycle start. So G55 now loaded. And you can as well. So I want to fire up coolant or something like that. All right. So TSM screen is just a quick way for you to set temp zeros, maybe in a setup type of mode. So these are relative zeros. You can measure workpiece if you want to start establishing real zeros based on work coordinates. Your workpiece, we've given you 3 basic cycles that come standard within the control. You'll have a simple edge kick, a tool that's appropriate for it. In this case, I have a tool which is tool number 4. That's why I'm leaving it alone. But a basic edge kick will come in into 0. So I want to back out, and let me go put in something a little more realistic. I happen to have 1/4" end mill for tool 1. I'll come back over and put in the spindle. All right. Now we got this. Come in. Allows me to select writing to. Doesn't necessarily be the work coordinate that's active. Find the direction I'm measuring in. Define axis I'm measuring in. There are 3 axes. You'll see help screen pictures will update automatically. I move direction, and then what do I want to consider the edge when I'm done? From there, if I'm going to call it 0, I just simply hit set work coordinate, accurate coordinate. From that physical work coordinate, in this case G54. Now you see the display didn't change because G55 is physically loaded. I wanted to do it to make the date change. We could have had G55 here, set work coordinate. Now we're writing to G55. Feature. For the center of different features. Pat just wrote in real quick, having some problem with the audio. If anyone else is having issues with the audio, let me know. I'd be interested in knowing that, if it's something specific to his settings. Sure, definitely allows me to start establishing or setting zeros based on the center of a block. Here I can touch 4 points, and the system will automatically calculate and then set a 0 right in the center. I'm having some audio issues as well. Always fun when you have new tools. Okay, well, I think we'll have to deal with it for now. And I'll have to try to address it. And there, sorry guys for any inconvenience from the audio side. And also we have the ability of finding the center of round features as well. So I can come in, select 3 points on some kind of a boss, find what I'm going to set the work for, and I can set a 0 in the middle of that. We've just established some basic zeros. We'll go into the measure tool function. Allows us to set tool lengths. There are ways to measure tools within the system. We have measure manual or measure auto. If you happen to have on the system a tool probe, you can use tool probing in our system, and that would be under the automatic function. If I'm measuring tools manually, I still go to measure tool manually. I'm going to find with the reference point whether I'm touching off to a workpiece or touching to a fixed point. Position or location is going to be in my Z. Top of my part, I want to call it 0. I'm going to leave the 0, or maybe I'm going to put some small incremental value, plus towers or something. And then I can hit set length, and it will write to whatever the current tool is in the spindle. That tool that I would have just set. Set length, come down, and I'm there. If on work coordinates, you'll see that the numbers will update. We were on relative. That's why the numbers weren't initially updating for us. So there we see that this is now zeroed out in Z. We also see that quarter inch we were off before when we were saying the zeros. So you have to use the tools to be able to set up a job. One extra function called face cut. We can basic computational cycle to say face off a part. From there, we can pick our chins. You fill out this page, it writes a mini program for you. You can hit cycle start, and it'll actually run this little facing routine. I want to show you in this function in the offset table, so you can kind of see where everything's being written to. Select the offset table. You can see this is our standard offset table. The table handle all of your tool length offsets. This is under the tool list function. Where that I want to compensate on a tool, I can select on the where field and define a where in the length or the radius. As well as your work coordinates are going to be here. So this is where it was writing to the tables when I was selecting the different work coordinates and telling it to write to. It's writing to this work coordinate area right here. So all offsets are found under the hard offset key, which is in the corner. Little 6 buttons right here where you have your machine program. These are your navigation buttons. You'll find set table. When I look at my tool list, I have some pre-created tools here, some stuff that I set up for this job. From there, I can create end mills, taps, so a bunch of different configurations. Creating a new tool, I'm going to simply select the new tool option. Pick the type of tool I want. So these should be your 4 common tools within the system. You'll notice that the tool library is reduced from the advanced controls, specifically because of the marketplace we're leveraging this control in. I can pick a milling tool, let's say, a milling tool. I give it a unique number. In the 808, all tools are referenced by a physical number. So if I didn't have a number 10, so I can type in number 10. I just hit an end mill. I do the same thing with drills, taps, or ball end mills. One thing that certainly is unique to is the ability of creating multiple offsets for any given tool. So I created a tool 10. That would be a physical end mill sitting in my carousel or for my machine. Select the edges function. Right, there's a soft key, 3 for top, offset edges, and I create a new offset, or what we call a new cutting edge, for the give tool. So I have two tools are associated to tool 10, but I have separate cutting edges, number 1 and number 2. We'll call that in our part programs, I call it D1 or D2. If you don't stipulate the number, it will default to D1. But as you see some programming examples, we'll talk about that a little bit. So that's a basic run through of the system from jog setup functionality. We'll jump back over to PowerPoint. So I want to give me a second here. Still getting used to this. All right. Let me see. Okay. We're back on our PowerPoint. So here what we're going to do is we're going to transition into doing an actual programming demo. Some of the things we're going to talk about is first how to get into our Program Manager area. Once we create a new file or a new directory, and then show you what the editor looks like, show you the CAN cycles, and we're going to contours, we'll do some drilling routines, maybe a facing cycle. We'll get a chance to play around with the simulation mode within the control, and to our live demonstration portion. What I do want to do is I want to kind of refresh your memory on print. Let me bring it up real fast. So this is the part we are going to be working on. Basically what we have here is we have a 0 location. We'll treat to be the upper left-hand corner of the part. We're going to roll around the shape. We'll face off the top of it. We're going to face it off with a 2-inch face or end mill. We're going to profile it out with, let's say, a 1/2-inch end mill, and then we're going to drill that 4-hole pattern with a 1/4-inch drill. Okay, so let's switch back over to screen. There we go. We should be seeing our Sinutrain, and we're going to initiate creating a new part program. What we're going to do here is we have to get to the part program area by selecting Program Manager. The 6 navigation buttons we were talking about earlier. And we just select Program Manager. It's got the 4 kind of boxes that are representing like files. Select Program Manager. It's going to put us over to the Program Manager area. I have options I can do here. First, I can handle programming in alternate areas. I can from standard with a USB port. I can access the USB by selecting the USB function. It would show me whatever's on my USB stick. RS-232 is also standard when there's control, so I can communicate via RS-232. U files is actually an area on my hard drive where I could have part programs. You set this up maybe to be a network path, depending on if you have an advanced system or not. In the advanced system, we do support networking capabilities. Or within NC, which is our system memory. See, this is where you're going to create most of your standard part programs or bring them in for operation. I can just part programs right here in the base directory or folders. So in this case, I created a folder called Programs. Maybe I need to do a folder, so I can select New, and then Directory or File. Create a directory called, I'll call it Sample for the programming we're doing today. Type in the name, hit select OK. Programming folder. You can go up or down, use blue arrow keys on the screen. Select Put, and it'll bring you into that folder. You're always going to get this first folder with the 2 dots. That's just allowing you to back out of this folder. So I can put back up, maybe go in Programs folder if I want to see some of the programs in there. So you can start to navigate through just using your arrow keys and input key. Went in to the program area where you want to create your part programs. You're going to select New again, and you're going to New File. and you could multiple directories if you want, but you get a new file, and you're going to name the part. So when it comes to a name in our world, in the Siemens world, you're allowed to use letters, numbers, and underscores. I don't want to do any other characters other than those three areas. So I could call this, let's going to call this example underscore 1 for argument's sake. In the program name, I don't have to worry about the extension. So get a solution for me. Once I say OK, OK now, and it launches standard editor. Point, you see there's some horizontal and vertical soft keys. We'll go through them as we start to use them. And my cursor is sitting at the top left corner, waiting for some input. Now, when it comes to the 808 control, it is a basic G-code control with what we consider conversational help functionality. When I say conversational help, it means when I go to a more advanced technology cycle, that's like a pocket, I could click on milling, click on pocket, and type a pocket I want to machine, and it will bring up a conversational window. Here, I fill out the cycle conversationally, and it'll kind of take us through the cycle, and we'll see that when we do the facing cycle. And when it's all said and done, it will have inserted that cycle into the G-code program. But you're familiar with basic G and M code structure when you're programming in the 808 control. This is very similar to the G-code side on our 828 and our 840 control. And in fact, if you're used to some of the what we call shop mill, shop turn classic systems with code side of those, this is pretty much identical to those. So for you that handle multiple controls, I would consider the 808 very, very similar to writing G-code in what we call shop mill classic. And that would be the pre-operate shop mill, shop turn systems. Okay, so some of our normal commands that you will get used to for the line, or what we call the header line of a program, would be a G17. That is our tool orientation. So is the tool oriented down, or G18 or 19 on a specific side plane? So right now the tool is oriented in an XZ or an XY direction, so it's pointing down. I want to call up what work coordinate I'm using. So I use G54. Only I might want to tell the machine I am in an absolute positioning mode as opposed to incremental. So absolute would be G90, G91 would be incremental. Then I'm going to tell the machine that my to measure are going to be an intrametric. For G70 is mode, G71 would be a metric mode. About that first line of instruction, you're going to hit the input key, or in my case, I'm just using the enter key on my keyboard. It's going to be down to the next line of instruction. Then I do tell the machine what tool I'm using. So I'm going to face off the part, and said that my tool 2 is my 2-inch face mill. So I'm going to call up the tool by stipulating a T2. Get in the habit of telling it my tool set by calling up a D1. Again, you have to use the D1s, but if you ever want to start to use multiple cuttings, you need to start to use them. So I like to get guys in the habit right away. My tool 2, my D1, and here I could even put in my M6 to indicate my tool change. Tool instructions may change from builder to builder, but it is very, very typical to M6. If you want to add comments, I simply put a semicolon on that line and type anything I want after that. So if I wanted to say this was a 2-inch face mill, I could do that right there. I'm probably going to want to fire up my spindle. So I'm going to give it some spindle speed. We'll just go 1,000 RPM and give it a direction. We'll start up in a clockwise direction. We want to tell it how I'm feeding. So 2 primary feed moves. 94, which is feed per minute. We say feed per minute because it'll depend on if it's inches per minute or millimeters per minute, depending on what the system's set to. We have G95 feed per revolution. We'll do feed per revolution later in our drilling example. I'm going to tell it I'm going to do a feed rate, and let's just say 20 inches per minute. This would be a very typical statement. Maybe at this point, if I wanted to use coolant, I could type in M8 for coolant. Sometimes there's like to maybe pre-position the tool close to the part. So I use maybe like a G0 command. We're going to get close to it. So I'll go X minus 1, remembering that our 0 is the upper left-hand corner of my part. And we'll get within Z of 1 inch. And we fire up our coolant. Now ready to go into some function. So we said we were going to face off the top of the part. Certainly I don't want to have to put in every single move for a facing cycle. In this case, I'm going to go back into milling. I'm going to select the face milling cycle. Face milling, I start to fill out the page. Question is a retract plane. So we want to retract when I'm done. We'll go 100 thou off the top of the part. Would be top of my part what I'm machining from per se. So let's say I had, I don't know, 50 thou stock on the top of this part I wanted to face off, and it was in the plus. So I'm going to give it positive 50 thou. And you can even see the little help window kind of defining what variables mean. We have our safety distance. That's really how close do I want to get to a part. And this is usually an incremental value. Our word is an incremental value. So I'm going to say you can get within 50 thou of a part in a random mode before you start feeding. Depth, D would be the absolute, and that's why it says ABS right to the right of depth, right here in the top upper corner. And it would be the absolute position that I'm ending at. So the top of our part is going to end at 0. Starting point, where does my facing cycle relate from? Well, the upper left-hand corner, so that's going to be 0. And the S and PO represents the Y, 0 and the Y. Now we're all length, so let's say that part a little bit bigger, 4 1/4, and this direction dependent. So my plus minus will define the direction. So if I want to come down in my Y, I want to go in a negative direction of Y. So I'm going to do negative and tell it 3 1/4. We'll quarter on our rough stock. All right. If I wanted to angle the entire cutter path, maybe on a 45 degrees or something like that, I could. Then it would take this whole routine and pivot it on the 0, 0 location. So it wouldn't just make the cutter path angled over top of the part. It's actually rotating the whole cutter path. We're going to leave it alone. I can put a 0. Maximum in-feed depth. So maybe I don't want to take any more than 3 thou per pass. So I can take a smaller cut. Max feed width would be your radial engagement. So 50% of the cutter, or 1 inch, since it's a 2-inch cutter. Okay, direction of cut. Finally, for my retract, I'll give it 5 thou. 25 is fine. Allowance in depth. So if I wanted to leave a finished cut, I could right now. About it. Give feed rate for my rough machining. Would be how I want to mill my strategy. So if you keep an eye on this window right here where it has the example of like our help screen, if I toggle this, you're going to see that the change. And really, do I want to bidirectionally machine, unidirectionally machine, make sure that there's an overlap, a whole bunch of different scenarios here. So pick whichever one you want. So I'll do a little bidirectional cutter path here. And then overall feed, so it would be like a lead in. So we don't want to lead in by 1 inch off the part. In any of these fields, if there's any of these variables you don't understand, the system automatically has the help functionality built in or manuals built in. So if you simply hit the help button, you can get more detailed descriptional information. Usually I'll come in here if I want to look at the variant sections to see maybe the different cutter paths or whatnot. This will get a lot of information about the cycle we're looking at, or any of the cycles for that matter. And exit back out. Okay. That will save the cycle. So it saves it as a G-code type of cycle. At any point in time, as long as the highlight is on the cycle, you can hit the repile button, open up conversationally, make change, hit OK, and that change will take. Now you see with me, I just inserted it in the wrong spot. I started below my coolant command, so I'm just going to move up fast, put my coolant above. Now, one thing I like to do myself before I get too far is I'll do maybe give it an end of program statement, because I like to simulate in stages. And see how the simulation function works right now. So I can jump over to simulate by clicking the simulate button right here. It's the lower corner horizontal soft key. I delete the window of something that was previously there. And now I can select auto. It's going to tell me to be in auto mode. My cycle start button will create my simulation. That's a little different to some of the other controls. Okay, we've set it up in the 808. Here it shows me to scenario for the numbers I gave it. It took 3 passes basing off the top of my part. This first left lead in was that 1-inch lead in that I gave it. So you start to play around with the different routines and see it modify your cutter paths. Okay, like what I see and I think I'm good, I'm just going to hit the edit button. It's going to come out. I can imp down to give me a blank space, and I can continue on with the program. In this case, I want to now profile my shape. This would be a perfect condition for a tool change. And commonly, the image up here for my tool and my spindle call, that's going to be pretty much the same information I'm going to use over and over again. So if you want to, you can move up and you can start to use our cut, copy, and paste commands. Copy paste works is first I have to mark or highlight the items I want to copy. So the mark on button with the blue arrows, or in this case I'm using the arrows on my PC keyboard to hide over top of the info I want to copy. Highlighted it. I can click copy, move my down, click paste, and it's just a very fast way of duplicating information. So in this case, I want to change my cutter to tool 1. I want to change the note right here. I tell it this is a half in, typo. And so now I have a quick little note here. Maybe I change my spindle RPM or my once I continue on with my part program. So we just did a quick tool change at this point. We loaded up tool 1, which is my half-inch end mill. I'm now going to get an opportunity to see how we handle array shapes. Section, what I need to do is I first need to go over to milling again. You see the second function from the top is called contour milling. Contour milling handles irregular shapes. By selecting contour milling, it's going to mean I'm going to start to define the contour milling cycle. So the first thing it asks me for is some reference name of the shape. And this is for your own reference. You could have multiple shapes in the same part with the program. In this case, I'm going to just call it OD. So it's OD, hit the input key or the enter key. Now, before I go any further, I'm going to click on one of two options, either new file or attach contour. So on attach contour, start to create a contour for me below M30 statement. Holds all of these calls for you without you having to know all of this type of syntax. And once you do this, all you have to do is click on the contour button to the right of edit, and what we call our contour editor. So the contour editor allows you to start to draw shapes right of control. So you draw any regular shape you want. First thing you have to tell the system is starting point for the contour. I'm going to let 0, 0, which happens to be the default starting point, so I'll accept that element. And use your lines and your directional moves and arc moves to draw the shape. So let's say the upper left-hand corner, 0, 0. My first move is going to be going to the right. Do a horizontal move, so I pick the horizontal button. Tell the X to move over to the end point of that line, which I happen to be looking at the print, so I know it's 2 is over. Type in 2, and it starts to draw the line. If I want to do something at the line, like a radius or chamfer, I could. In this case, we're going to write into an 1.5 inch radius. Simply going to accept this element. So what happened? Well, just a line, but more importantly, if I look to the left side of the screen, I get a second little icon here, and that's element. This is how you keep track of the items you draw inside of your contour. Continue further, you're going to see it's just going to build more and more lines. Sweep around an arc. So I'm going to pick my statement. direction, clockwise or counterclockwise. The rest, 1 point, which I want to go to. This print happened to have called out the endpoint as 3.250 and a Y location of minus 0.71. At this point, I haven't told it anything about the center. Now, what the automatically did, and what I'm going to do is I'm going to zoom in so you can see it. In a second here, we'll zoom it in so everybody can see it. Be a little hard to see, but what the system just did was it's now calculating the potential of 2 arcs. I know that because I have this dialog select question on my screen. So the dialog select which of the 2 potential scenarios, and you see how the center point changes as I toggle them. Pick the one you want and hit select. If you pick the wrong one, you just hit the change selection key. It'll go to the 2 scenarios, and I could pick the other one. Very common when creating arcs, you have 2 potential scenarios because you have 2 different center points that could have calculated with the same endpoint radius. I filled out the page. I don't have any transitions to the next elements or end-of-line racers or chamfers in this case, so I'm just going to accept the element. I'm going to do a 2-axis move with my X button. Now, I'm going to keep this simple. I'm going to tell it that I'm coming over to an X of 4 and a Y of negative 1.82. Accept it. Come straight down in Y with the vertical button. I'm down to a 3 position, which is negative. There, I want to chamfer, so I'm going to change my round to a HR statement. There's my chamfer command, or type in a chamfer of a 1/2 inch. Accept it. Chamfer come up until I create an element. So in this drawing, I happen to be moving back to a positive 1 inch. Now I see my chamfer came up, and my move came back. Element. You can play around the zoom and stuff to kind of get a good idea of what you're seeing. The 2-axis move, we're going back to a position of x0 and a y of minus 1.5. I'm going back to my starting position, which in this job I happen to be. You don't have to. I can either do a move up and tell it to end at y0, or if you click on the More button, function called close contour, and that'll automatically just run it right back to where you started from. I have my little element tree. It's been built up. We'll come in a second and maybe edit something, but now, so I simply want to back out and get accept key, one final accept. We'll put back into the program. If you look, it just created the whole area. This is what the contour is. Now, what I want to do at this point, once we've created the contour, we're going to simply hit the Teach Interface button, right-hand corner. It's right back into the cycle that started all this. It's going to finish filling out that cycle name. So OD and then the colon OD_E is just the start and end of the cycle. It's all the same. From here, we have very similar variables to what I described before. We have a retract plane. Where do I go? I'm up. Reference would be top of my part. Say distance, how close I want to get. We'll do a 1/2 inch deep. Mid feed unsigned. It's your depth per cut. It's unsigned because it knows the top, it knows the bottom. Finish allowance. I'm not going to worry about finishing this example. Finish allowance at depth. I'm not going to worry about it again. Feed rate for surface machining. We'll just run 20 inches per minute. For feed depth, maybe I want to slow it down a little bit in case I'm clipping some part. You can define what your cutting scenarios are. It's roughing, is it finishing, and you threw it just like the other technology before. And if you go to the help screen, it'll give you more detail on each feature. You can define our cutter comp left, cutter comp right. How to exit the part. One would be a straight move. We could do a semicircle or a full or a quarter circle or a circle. So basically either a 90-degree or an 80-degree arc. Leave it as a line move right now. What's the distance of that lead-in move? So maybe I'll use a 1/2 inch. Tracked feed rate. So maybe I want to keep it 20 when I'm retracting. Also left it blank. do I want to come out of it? So maybe I'm going to come out with an arc. You see something different. So we're leading with a straight move, leading out with an arc. And the radius of that arc, we'll do a half inch. Let the page. Once you want, you hit OK or accept. This point, we can go over to simulation. The window, if I want to start everything from scratch, start. It'll show me my feeds, and then I see it profile. So there we're going around the profile. The little hook at the end, that's the lead out. The straight move in here was my lead in. So I created a part of the profile, this part with multiple depth cuts. The slider, you can look at both a view, a front view, a side view. So if you want to see the depths of cut, you can have a 3 projected view if you'd like to look at that. What we do in the 808 is a 3D view that is reserved to our higher end controls. So I am good here, so I'm going to continue moving on. What we're going to do now is we're going to add some drilling. So in this case, I want to come back up, and let's say I'm going to copy these because I have to do a tool change to my drill. So copy it, put it in. Make sure that I change to tool 4 because 4 is my drill, and change our comment real quick to read. Be, I believe, a 1/4 inch drill. So if not now, 1/4 inch drill. All right. Maybe I wanted to change my RPM to some other RPM feed rate. Now, I mentioned that we have 2 different feed, which is per minute or feed per rev. So let's say I was in drill, I wanted to do feed per rev. I could type in a 95. And then my feed rev, so I'm going to do 5 thou per revolution for my advanced. In this case, maybe my pre-position, I don't need to go far apart. So I'll pre-position to 0, 0, an inch above the part. Remember, down from tool change at this point. Turn to coolant. I'm going to go in and drill some holes. So I'm going to jump over to the drilling. There's a whole host of drilling cycles. I'd love to go through each of them, but we don't really have time allowing in this short a time frame. But you have a basic drill centering, which feed the depth to pull out. Center drilling gives us the same basic path, but I can also ream, which is feed out, feed back in, and I can start establishing dwells at the bottom of my holes here. Deep hole drilling starts my pecking cycles. Then I have a boring cycle for single point boring, threading, and then I go into my patterns. So we're just going to keep it nice and simple at this point. So we're going to do center drilling. I'm just going to do the standard drilling. And now we're drilling cycle. So what I do need to remember is I need to turn on the modal call. Don't select modal call. The system would just drill a hole wherever she was currently sitting. So in this case, I pre-positioned it to 0, 0, so it would drill a hole there. Once I turn on modal call, I'll get a little red call statement below the cycle 82. Now it's going to modally drill with whatever come after this cycle. So I have my retract plane, just like we reference, top of my part, safety distance, depth. I have a 1/2 inch plate, so I'll go a little bit deeper. We'll go 5/8 deep. I wanted an incremental depth based on my RFP, or my reference plane. I would use my DPR. That's what that means. It's relative to reference plane. So you're drilling on like a lot of different surfaces. It's just a simple way to your depths without having to adjust the absolute. You could define a dwell for my holes as well. In case we're going to leave the dwell at 0. I'm simply going to select OK. Set up your M call, so your modal statement is here. I could just do what we traditionally would be used to, which would be do a bunch of rapid moves at this point. So I could do a G0 and tell it my X and my Y locations. Or you can use our hole pattern function. What hole pattern does is it allows me to do a simple interface to do holes, and you can do up to 5 holes per vent and store as many of these as you like. I can do holes or rows of holes, or I can do patterns here. So this would handle those basic functions. In an area we're doing random, So I'm going to come to the arbitrary hole field, give it the coordinate for my first hole. So I'm going to tell it it's 5/8 over in X and minus 5/8 down in Y. My next hole happens to be 2.125 over. I am my Y, so I do not have to put it. I'm going to now position down in my over in my X and down in my Y both at the same time. So I'm moving over to an X of 3, but I'm dropping down to that one lower right-hand hole. Going to be 2.75. I want to back to my fourth hole. That's going to be at a position of 1.5. Your holes. Once they hit accept, it's a cycle. Put it in our spot. Okay, so we are going to just mark out real quick. All right. Highlight down. Okay, so copy it from there, paste it, and then back up. What I have this stuff again. Hit my delete key. It's gone. So now I have my mqual statement, my pins, and now I end it. I show my drilling. We're all familiar with a G80 type of statement. In our world, we do another mqual. But in the 808, under drilling, I have a deselect modal function. What it'll do is that'll automatically insert an end of drilling cycle called mqual. So it should between our modal call, that's what mqual stands for, modal call, is what's going to drill. Okay. Well, I'm done. So maybe I can shut my spin off. I'm going to shut my coolant off. Simple statement in our world for doing a retract position, tell it to come up away, is what we call a SUPA statement, S-U-P-A. SUPA stands for, it's a temporary suspension of the active work coordinate. So basically shutting off G54, but it's a non-modal statement for only the length of this instruction. I want to be in a rapid mode. I want to my tool offsets. So that's done by giving it a D0. And then I want to just tell my Z to go all the way up to Z0. And assuming I'm on a machine that machine coordinate 0 is established at the very top of the travel of Z. We're going to do one final simulation. Do a simulation again, and we can just see it cross. It'll do. Just see it do the profile and then the drilling. Okay, the coordinates for the drilling. We had it from a front view, and you can see the lines that are coming down for our 4 holes. There's a drilling, pecking cycle, but you get the gist of it. Okay. So at this point, we can now let's say, for argument's sake, I wanted to edit the contour. Maybe I input that was wrong, or it was something I didn't like on my contour. If you bring highlight down below the M30, anywhere within the contour, the recompile button, just like before when we opened up that one can cycle, put you back to the contour editor. On the left side, if I move my highlight up or down arrow buttons, right? If I move my arrows, this little orange button changes. So you simply just move up to the element that you want to change. See, on my downstroke, I want to change the chamfer size. I can come over by selecting the blue arrow to the right over. To the chamfer, make whatever change I want. The change, I simply hit accept the element, accept one final time, updated the cycle. So I don't ever actually have to worry about this kind of gibberish down here. It's tracking what the cycle is inside the contour editor. Get it? I mean, the points make sense. Here's all the lines and positions, those stuff. It kind of creates that propagates the graphical editor. What we'll do real quick, we are running a little short on time. So let's just jump over to auto mode, and then I kind of want to open up the floor for any questions that may have arose or questions you guys might have on other topics. So if it was time for me to actually run this part program, I can simply, since I'm still in the auto mode, because I'm auto from simulation, I can simply hit the machine button. Machine will switch me out to whatever mode I'm here. So with the machine button, I'm either going to go back to job, point, hand wheel, block, or auto. Back to auto mode. I hit it. Machine puts me into auto. Now I'm in our auto. From here, I can hit cycle start, and the machine would start cutting my part through based on the feeds and speeds I have. Goes all the way through. We do have real-time simulation, so I can turn on the real-time simulation window, and now as it runs, I'll get a representation of where I am on the part at that point in time. You can turn this on or off as you go, so I can pop out of it with the back key if I wanted to and come back in. Probably the only other thing I'd want to show you guys from an auto side is how do I start in the middle of a program, and that is using the block search function. So when I select block search, it's going to back to what looks like my program editor. But this move your highlight up or down to wherever you want to start. So I'm going to start at tool 4. We'll modally scan to this point, so I can theoretically start at 8 and it would still catch the tool 4 and change to tool 4. So once I've decided the point I want to start, I want it to automatically scan to that point. I need either to contour or to end point. Difference in the two, and you can read up a little more when you get a chance. But is really, do I want to start right at the position I'm telling it, or do I want to kind of lead into the position? Here it really makes no difference. So I'll just say to endpoint. Pre-links that position, scans to it, and it's now waiting for a cycle to start. So I was to bring up my real-time simulation just so you get some kind of acknowledgement of what it did. I'm going to select cycle start once. You get a second question. You sure you want to start in the middle of the program? I say yes again. Does my 4 holes. And we can zoom this. I just deleted one more. You guys should get the overall gist of it. You can also control different things you're doing within the program under your program contour program controls button. Tasks would be, running without the servos physically moving, just kind of parses through the program. You can run feed here. You can do different stop statements, block skips, how the single block function works. There's a whole bunch of different functions within here. We can certainly leave for another time. Okay, so what I'm going to do right now is, if anybody has any specific questions, you can certainly pop through the chat window. And we talk about maybe some of the details here. Now, remind you as well, if you have a question on other topics related to Siemens, by all means, if I notice, I will certainly let you know. Great control. Thank you very much. I'm actually impressed with its capabilities. The 808 is a very market-sensitive control. So it's actually a very, very reasonable control integration, and it gives you a lot of functionality for that part. Greg here, can I use multiple inputs on the same line? You can. I do have to double check many. On the 828 and 840, I believe we support up to 7 inputs per line. I don't know what the limitation on the 808 is, but you certainly can do multiple encodes. What I did with the M5 and the M9 statement. Also, he asked, does it support USB key mouse? I had it. That's a good question. I don't know as far as on the machine. I did, because most of the screen on my APC, a lot of functions I would have thought would have supported them don't, so probably not. Is this presentation file available for download? I initiated a recording, so I'm going to see about what it's going to take to post this recording. I know the tool lets you come in and listen again. I don't know if it'll be downloadable, so hopefully it will. I will let you guys know. Asked, get the PC program from. It is from CNC4U.com. So if you just go to www.cnc, then or, and then OU.com, you get 808 MTC there. Use these controls outside of the country. In India, it looks like. I don't know if they're marketing them in India, to be honest with you. The control itself was originally developed for the Chinese market. We have been very successful in selling it in the Chinese market. I don't know if they've brought it over to India. I would assume they probably would. It's possible to stop in the middle of a cycle, move an axis to an intersection part, and restart. That's a very good question. That was from Larry. So basically what Larry's asking is, what happens? I'm in the middle of a program. I want to do a retract. So Siemens World, what we do is we'll be running in a cycle, and I should hit cycle start. At this point, the jog screen, I have part program. I could move, maybe move some location, get it away, do what I'm doing. Now, if you go back to auto and you cycle start, we should vector back to where I was in this repause mode, come down and continue cutting. So you can do that at any point. So go through the sequence of events again real quick. Remember to cycle stop. You cycle stopped. You're not going to hit reset. You're going to simply hit jog, wherever you want to go, spindle. Where the spindle will restart automatically may be a poor TLC, so I don't want to speak for that. That could be changed by an integrator. But from there, go back to auto, cycle start, and it should feed down and continue cutting. Right. From a full G-code, do you get a full G-code program? I'm not sure I completely understand the question, but what I will state regarding the G-code side, this control supports two different fundamental forms of G-code. You have a DIN standard and an ISO standard. The standard is the functionality of our programs that we comply with, and that's kind of our formatting. The ISO is your FANUC style system, and you can run ISO programs in this control. There's a parameter change in the back end. So you can bring FANUC programs into this controller and run them. Maybe that's what Wayne's thinking about when he says a full G-code program. If it's not, by all means, just shoot me back and we can discuss this further. Dan also gave the link for the download. Dan, if you want to retype in, you should be able to share it to everyone. They can get the link for the download. It looks like you're going through the US site. Really, you'll get it from either site. Danny just made it for all panelists, so you guys in the chat window should see here to get that. All right. Wayne, can you reverse process from G-code to yours? Reverse process. Nothing here. Wayne, if you're okay with it, I'd like to unmute you, and maybe we can talk a little bit if it's fine. Hopefully you have a mic. It looks like you do. So Wayne kind of unmuted you. Did that work? Shuffling around. Wayne? Oh, you don't have a mic. That's too bad. All right. So you said DIN standard. Let me just mute that again. Reverse process from G-code to yours. I guess. Well, let's talk about this a little bit more. So many of these CAN cycles, if you're building out of a CAD/CAM system, let's say, they can run the cycle the way it looks. So what happened is, even if this cycle 71 is being posted from a CAD CAM system, you most certainly should be able to come in and let's come down and open up with recompile function. Data mask, or the conversational field, really just propagated by that cycle. So our be posting from an outside source, as long as they're following our protocol, they're building the cycle as reads here, which they would need to just get the cycle to run. You should be able to open it up conversationally. So maybe that's where you were referring to. All right. Yes, it was. Great. Thank you. So I see we're just a little past the hour. If there's any other questions, by all means, shoot them out. If anyone wants to open up a dialogue and they have a mic, we can as well. Give it just another minute or so. Thanks for feedback, guys. What we'll do here is, if everybody's good, here shortly I will close down, and I'm going to save this or shut down the recording, and I will shoot it out to everybody, the link. So hopefully after this fact, you'll have to tool for us, the WebEx tool that we're using today. So we're still kind of learning, but seems to be working pretty good. Thanks for everybody's great comments. All right, so I'm going to stop sharing my screen at this point. Okay. Now, at this point, I want to just thank everybody again for attending. I'm going to end the event, and everybody should have my information. So if anybody wants to have some further discussions on any of these topics or further topics, by all means, reach out to me a lot. And again, I appreciate everybody joining us today. Take it easy. Bye-bye.